Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Well, hello there, and welcome back to the Digital Enterprise Society podcast. Thanks for coming along on the journey of this show that we have designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, be sure to visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show with Craig Brown, an industry veteran and a former PLM leader at General Motors. Hey, Craig, how are you today?
I'm great, Tom. Looking forward to our interview. This is a little bit different today. We're going to take a deeper dive into manufacturing. So this will be interesting.
That's good. I like it when we get a little different. You know, we do kind of cross a lot of areas on this show. It's been a lot of fun for the last 6 or 7 months. Each week, Craig and I try to bring to this podcast interesting interviews and other ideas to help all of the listeners enhance and grow their careers. And today is going to be great. Today we have Mo Abuali. And Mo is the managing partner at IoTCo. Hey, Mo, welcome to the Digital Enterprise Society podcast. Yeah, thanks for coming.
Hi, Craig. How you guys doing?
We're doing great.
So, Mo, what's your background? How did you get started, and how did you get to where you are today?
Yeah, I'm an engineer. I'm actually an industrial engineer, and I graduated from the University of Arizona. In fact, we call it systems engineering, but it was part of the same department. Worked in IBM for a few years. It was my first job out of university. I was part of a maintenance organization. I was doing reliability center maintenance of hard drives, very large hard drives for the finance industry back in the 90s. So I learned a lot about RCM, reliability center maintenance, and then I moved to manufacturing. I started working in a process company, which we made cement. And our organization was responsible for process engineering. So I took a deep dive and understood how equipment works in a manufacturing setting, making cement, which is, quality is key for the cement industry. And then I moved to the automotive industry, very fast-paced. I worked on Toyota, TMMK, Georgetown, Kentucky for a few years. I was part of the R&D department of Toyota, so we actually interfaced with the maintenance organization, and I was responsible to deploy predictive maintenance activities in the Toyota facility in Georgetown. Yeah, and then I left manufacturing. Actually, I went into the software space. So, rather than being the end user, I became the vendor supplying software to the manufacturing company.
That's excellent. Mo, I think a lot of folks don't realize when they start their career that sometimes the operational job will lead to a development job, meaning that you learn something helping predict reliability, or in the case of the Toyota experience, how things work in a manufacturing plant. And the next thing you find yourself doing is maybe creating a better way to do things. Is that what happened with you? And somewhere in there, you finished your doctorate work as well, right? So maybe you can elaborate on that a little bit.
Yeah, absolutely. I was actually blessed. I did my PhD part-time at the University of Toyota, and I was very blessed to work for a National Science Foundation research center. Cool. This research center was, it's a long acronym, IUCRC. It's Industry University Cooperative Research Center. See, my mind is good, And it's not your theoretical research. It's actually applied research. So my dissertation came out of the work I did at Toyota and several other companies. And I did that for about 5 years. So they're very practical, and it really taught me how to deploy R&D in a very practical setting while doing my PhD at the University of Cincinnati.
So I think that's one of the important things I learned early on was the pragmatic or applied work that goes with your particular interest. I started out with, aerospace engineering, but that led to doing embedded controls first for aircraft and spacecraft, and then eventually for cars. And then once you're in the car business, you have a similar experience. Then you get exposed to all other kinds of things, including mass production. You mentioned a bit about process engineering in the cement industry. Can you just describe how that also applies to your other experiences, the point about processes and process engineering?
Yeah, absolutely. So I was actually part of the quality organization of a large
Hmm.
cement manufacturer, and I did quality testing of the actual cement, and we were trying to do traceability of finding out what is the root cause for quality issues in the cement process. So we
So,
actually, took the quality data and we were tracing back to the actual, mixers and ovens and kilns that were actually making the cement, and it was interesting to see the birth certificate of what is actually happening and what is causing the downtime of or sorry, causing scrap issues in the cement industry, because obviously it's safety critical. You don't want bad cement to be shipped to
so,
construction.
so this is interesting. So in the car business, we're all about this part traceability thing. That's what comes up in these discussions. In a chemical business like a cement, are we also tracking the material source, I guess you would say, the raw material source? How do you do part tracking for something like raw material like a sand and whatever else goes into cement?
Yeah, actually, we had very stringent quality and traceability flow analysis back in the
Hmm.
company. The company is now owned by Lafarge, which is a large
Hmm.
cement organization. But we obviously cannot track every single millimeter or ounce of cement you're making, but we did it in batches. So the batches were inspected, and we had a special quality inspection procedure that ensured that our inspections are catching defects across the process. So it was based on batches. It was batch quality management.
Hmm. Okay. And then of course the process is things like, well, how long was it in the oven, or how long was it mixed with water, or whatever the catalysts are, right?
Correct. Correct. Yes. I
Interesting.
I also got trained at the same time in the actual SCADA systems, the
Hmm.
control systems that were running the process that makes cement.
Right.
And we used Allen Bradley PLCs at the time. It was in the 90s, so the equipment was a bit older, but there was very strong SPC. There was real time measurements being produced. These decisions, though, were made manually by operators. So by looking at data right in front of you that is captured, you kind of had a green, yellow, red buttons in a control room setting, and you can
Hmm.
press green, yellow, red to make a change to the process manually. So there was, even though there was automation and data collection, but the actual decisions were driven by humans, which manned the process 24/7.
So this is interesting. In today's era, we keep hearing, and in fact, it's in the title of the company you're working for, about the Internet of Things. And so a lot of us from the car business were like, well, wait a minute, we've been sensing what's going on the floor for a long time. And even with things like OnStar, we can sense what's going on in the cars during the life of the product, right? So what's so special about Internet of Things? You described really well how your equipment in the plant could monitor certain key things, and then an operator makes a decision. Does the Internet of Things, well, first describe it in your terms, and then second, does it get rid of this operator, or does it just make it easier?
Right. And I agree with what you're saying. I mean, IoT, in our view, has been around for many years.
Hmm.
I mean, at home, I own a Google Nest thermostat, and the thermostat senses when I leave my house and drive off, and it automatically fluctuates the temperature in my house to reduce energy or to create energy savings, right?
Hmm.
So, IoT devices have been using the internet to create value for customers and now for manufacturers. So when it comes
So
to the industrial Internet of Things, IoT, this is where inside a factory setting there is connectivity, there is data collection, there is analytics on the data that is leading to value and ROI for the manufacturing organization.
okay, so elaborate on analytics, because analytics in the past was a very talented operator looking
Right,
at a red, yellow, green button, right? Is
right.
that still that way today, or is it different than that?
It's definitely become more elaborate. So
Hmm.
today folks are doing a lot of performance analytics. They're collecting data. They're looking at historical data. They measure metrics like OEE, overall equipment effectiveness. Your uptime, your
Hmm.
speed, your quality. But typically, a lot of those metrics are in hindsight. It is not really telling you the true performance or health of assets. It's giving you a backward view, a chronological history of what's happening. So we are seeing more and more intelligent statistical, mathematical use of the data being captured that can actually give you deeper insights of, is this machine or asset actually healthy to continue being up, high level of uptime, and to continue making good parts on the factory floor. And there rises the concept of, predictive maintenance, near zero downtime operations, and even predictive quality, near zero defect operations, and using artificial intelligence and machine learning.
So the prediction then is you should service this piece of equipment at this time frame, otherwise your yield or your flow will decrease, right?
Absolutely. Funny enough, the reason we were hired at Toyota about 15 years ago was that they invested in IBM Maximo, which is a great maintenance system, but it was very static. It was not connected to the factory floor, and it didn't have intelligence. Maybe General Motors had a similar initiative.
Oh yeah, same tool. Keep going.
but our job was actually simple. Hey guys, we're collecting so much data. Why do I need an operator to go over my Maximo screen and create a ticket? Why am I not feeding intelligence to Maximo so I can even order a spare part before the machine fails? So we called it predictive spare part replenishment on the factory floor, and it was quite successful. But that was 15 years ago.
Yeah, and I think for the people listening who maybe feel threatened by this onslaught of analytics, what you all need to learn is what machines are really good at. They're really good at pattern matching and finding matches. They're really bad at making judgment calls at what to do with that insight. Now, some forms of AI and this machine learning stuff is trying to go down that path, but even there, the intuitive nature a human brings to problem solving is not something machine learning is going to, eliminate, at least in my lifetime. Now, will it happen someday? Well, this will be interesting to watch, but a lot of the hype, the IoT hype, and especially the machine learning AI hype, is just that. It would suit everyone to take a bit of a look at that. Mo, do you have that challenge in your company where you have to explain to people the limits of machine learning, or maybe where best to apply analytical procedures?
In fact, yes. Our biggest challenge is the education and the awareness around how to apply it and what is the return on investment from the application. So, in fact, we, as a company, we don't typically go in and selling the product that does predictive analytics, but we go in from the education angle. We actually have half-day classes. We have 1-hour webinars that we do. We have things to help manufacturers assess, where am I today in my digital transformation journey? What is my digital maturity? And based on the maturity, the technology can be, orchestrated in a special way, in a phased approach. You can create a digital transformation timeline for the manufacturer, so their people, process, and technology can evolve over time to meet their needs. But long story short, we first have to define what is the problem I'm trying to solve, what is the ROI from this problem, and then the technology feeds that.
That's what I got to thinking about. You mentioned maturity, and a lot of times, especially the short-term executives, they'll show up and say, well, I got to make an improvement, leave my mark, and then move on to the next job, right?
Correct.
And what I spent a fair amount of energy on was maturity models, and how do you know you're any good? Well, you got to have some reference point, right? Is there a standard standard might be overstated. Is there a common practice for a maturity model when it comes to digital transformation?
There's organizations out there like AMT, the Association for Manufacturing Technology in the States. There is NIST. I've been having some discussions and conferences, National Institute for Standards and so on.
Yeah, and we had Dr. Hedberg on here a few months back now, and he brought some of his insight as to what the challenges are. But continue.
Yeah, and to your question, I mean, some of those organizations are creating digital transformation maturity models today, while other companies have worked with also larger consulting organizations like PwC and Deloitte and McKinsey. They have proposed some topics in that area. We have our own digital maturity assessment approach at the IoT company. We try to simplify it a little bit. We are very focused on the digital side of things. So we assess how the manufacturer is connected, how they're using IT systems like manufacturing execution and ERP on the factory floor. And we use this in addition to the people factor to kind of create a baseline of what is their maturity today, and then understanding their future evolution as a company. We help them architect a phase approach to evolve and be ready for AI and machine learning in the future, if they're not ready today, right?
Yeah, and you reminded me of another topic. We both have an automotive background, right? And in car companies, the key metrics or key performance indicators that can tell you whether you're meeting your objectives as a car company might be really different than the key performance indicators of an aircraft company, or even a really small manufacturer who's building a one-of-a-kind piece of machinery, like a fixture or whatever that might go to a car plant. I think that's also part of it is you do need folks like yourself who can come in and say, well, let's be really clear what the problem is and what are the key measures that we would know are successful. And then just because technology is there doesn't mean you have to apply that technology. I think at least with older companies, one of our biggest challenges is we're running pretty well. So should we change technology just because there's some new technology out there? And it's always tempting because everything looks really attractive. And then when you get around to measuring the KPI, it turns out not to be that much better than what you already got, or maybe even it's a step worse, which is even a bigger challenge. Mm-hmm. Do you see this? And maybe tell us by industry segment, either size or however else you would say. Is there a kind of customer that's further along in the digital transformation than others, and what do you attribute that to?
In fact, yes, we work heavily in the automotive tier supplier space, tier ones mostly, and heavy industry, as well as aerospace tier suppliers and OEMs. We're working right now with a wheel manufacturer, for example. They make steel wheels, they make aluminum wheels for the automotive industry, and their assets on the factory floor are extremely old. I mean, they have steel wheel making lines that are like 40, 50 years old from the World War, literally. So it's not always so easy to get data, but with sensorization and with capability to use hardware units, we were able to capture data. So the point here is they're making wheels every 9 seconds, 9-second cycle time. And we were actually able to make a very accurate prediction with a 2-week in advance window lead time. And that allowed them to actually order a spare part that is tough to get for this line because of the age of the line, and receive it before the line actually went down and make a replacement. Now they have competitors. There's other wheel manufacturers out there that are maybe some of them are not using this type of technology. So the point here is, even though you are doing good, you're making your money, you're hitting your numbers, your competition is also trying to evolve, right? And you may underestimate your competition, but they're investing, they're putting technology, and they want to pass the bar. So I think the message here is, if you're not doing it, somebody else is doing it, and probably in your own segment, and you need to stay ahead of the game and be competitive using technology on the factory floor. By the way, they won this year the first ever Artificial Intelligence Leadership Award. I think I've never seen this award before. But the National Association of Manufacturing, NAM, with the Manufacturing Leadership Summit, they started giving this award this year, actually.
Well, I think that's good. It encourages it, right? And I also think there is an awful lot of I think it's noise, but I'm kind of an old crusty guy. But there's an awful lot of confusion about digital transformation. It's one of the reasons we decided to create the Digital Enterprise Society, and through talks like the one we're having with you today, maybe kind of melt the fog away a little bit about what's really happening here. Now, you gave yourself, or you have as the title, Chief Evangelist, and I viewed myself as that at times in the past. Why don't you tell us what it means to be an evangelist, and how did you know you wanted to be an evangelist?
I have an educational background. So when I was doing my master's and PhD, I was actually teaching, and I was an adjunct professor, and I truly appreciate the value of education, especially the folks that are a decade or so younger than me. I believe in the value of making folks aware of new technologies that can help them improve. And I fully agree with you. Digital transformation, there's a lot of hype, but we try to kind of clear the clouds and really focus on four things. We always start with the ROI in mind. Why do you want to digitally transform? Is it an uptime issue? Is it a quality issue? Is it a spare part issue? Is it a supplier issue? What is the true hypothesis that we want to solve by using technology? And once that ROI is set in stone, number two, are you connected and are you capturing the right data that allows you to deploy technology to meet that ROI? So we take a look at that. And in most cases, unless it's a big company, manufacturers are not well connected. The third is the analytics, right? Are you doing performance analytics today, like measuring OEE and fundamental things? And where are you on the predictive analytics space, right? So ROI, connectivity, analytics. And last but not least, now that we understand where the maturity is, we can talk about technology and selection of technology and scalability of the technology and cost and so on and so forth. So my feeling is those are the four things that would answer your question: ROI, connectivity, analytics, and technology selection.
Okay, so let me take you in a different direction for a second. So is it better to go get a data scientist from one of those best schools at this kind of stuff, who's got all the analytical skills, all the math skills, but maybe doesn't have any industry experience, and have them come in and be your digital transformation expert? Or is it better to take somebody who's been in the plant for 10 years, who has the aptitude to learn data analytics, and turn them into your evangelists of the future? What's your experience tell you?
So from personal experience, I mean, we have our own product that does predictive analytics, and we have a team of what we call industrial data scientists. So those industrial data scientists have worked in a manufacturing setting doing analytics. And I'll be honest, we have tried in the past to bring in folks from other industries that are more mature in terms of the analytics, like finance, maybe healthcare. But we've selected the route of bringing folks that have manufacturing experience. They know what a robot is, they know what a machine is, they know how things run, because that domain knowledge we find is key to allow you to do better analytics on the factory floor. So that's our view. But again, when we work with manufacturers, some of them have their own data science team, and regardless of their background, we try to create a center of excellence or competence within our customers, where we can spread the education and help them evolve to become industrial data scientists. And then they can maintain those systems on their own and scale them on their own.
Sure. And what I thought you might answer it this way, and I absolutely agree with you. To those of you that are younger out there listening, I strongly recommend you spend some time, if you're at a manufacturing company, you spend some time on the floor and just look at how it works. I remember one example of years ago where we were touring one of the GM assembly plants, and one of the other clients we are really associate, he had a similar role at a completely different company. As he looked at the floor, he said, "I don't get it. Where's all the inventory?" And I said, "Well, the line runs pretty fast, so the inventory's got to be somewhere." And the point is only through experience would I have known the answer to that. I would have never actually figured that out in classical textbooks. So I'd recommend you get some experience on the floor, and especially have a curiosity. Why does it work that way? And there's a lot of knowledge in the way a manufacturing line runs, especially a high volume one. And you don't want to underestimate that. You don't want to show up with all your fancy degrees and then say, "Oh, I can do it better." You might want to just understand how it works today, and there's probably good reasons why it works the way it does, right?
Yes.
So,
Be curious, listen and learn, listen to understand and learn, and then make recommendations to change. Yeah, I agree.
So when did you start calling yourself an evangelist? Was it 30 years ago, or was it 2 years ago?
So I'll be honest with you. I'm formally I'm a managing partner and the CEO of IoT company. I have two other managing partners, but I'm in the CEO role for all the operational and execution work. But I personally don't like to call myself chief executive officer. So I wanted to call myself chief entertainment officer.
Oh,
I said, hey,
well, maybe that would be better.
That's too much. So then I said chief evangelist.
Okay. Well, good for you.
But I personally have been doing a lot of educational, things by being adjunct faculty and so on for maybe almost 15 years. Yeah.
It sounds better than chief professor, maybe.
Right?
Yeah. So anyways, hey, Thom, this has been an excellent insights, and I hope people learned a bit about manufacturing in our discussion and the importance of that. And I'll hand it back to you.
Awesome. Mo, I was listening to you guys talk, and as you sort of talked about your own journey that you went through to get to sort of where you are, and this whole idea of being an evangelist and all that, a lot of people who listen to the show, they're maybe a little bit younger in their career, and they listen to someone like you, and they think, I want to do what he did. What sort of advice do you have for people to sort of take control of their own career instead of just being in a job?
I'm very grateful to the universities that I have spent time, like University of Arizona in Tucson, University of Cincinnati in Ohio. We had a very, very strong co-op programs in both universities. Actually, University of Cincinnati is probably a pioneer, nationwide regarding the co-op program that we have. I think it's important while doing your education, wherever stage of education you're in, to try to liaison yourself with industry, to have practical experience rather than just theoretical experience. So I think that has benefited me significantly because I had a 2-year internship co-op with IBM while finishing my bachelor. I had a 5-year very intense kind of special arrangement with Toyota. I worked through the National Science Foundation at an IUCRC that allowed me to work and live in Japan, in Singapore, in Taiwan. So also more of an international view of what's happening out there in the world and interacting with different cultures. I'm sure you're not surprised when I say this, but the way people make parts in Japan and Taiwan and China and the US and Mexico, maybe it's the same process, but it's a different culture and they do things differently. They work differently. So, find a good approach to have a practical career working with industry and try to have an international mindset, about how things are done around the world.
I think that's great advice. Hey, Mo, thanks for coming on here and sharing all of your insight and your ideas and your theories. I think that this is how people learn. So it's guests like you that make this show great. So thank you for being here with us.
Thank you so much, Thom. Thank you, Craig. Thanks for your time.
Yeah. Thank you, Mo.
And for everybody who's listening, keep tuning in every week. You can join us for more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.